Greetings, students. Today we're going to discuss Unit 2.1 in your notebooks. Let's begin. Slope is the constant vertical change divided by horizontal change, or you could say the difference, quotient, actually is the key word here, quotient between the vertical distance and horizontal distance. Any function whose graph is a line is called a linear function. Linear. Oh, sorry, I'm a little bit overexposed here. Let me turn the lamp down. There we go. The linear equation that relates two variables is given by the formula. We're going to use these variables here. Y is equal to mx plus b. Or sorry, ax plus by equals c. And it's commonly referred to as the standard form of a line where a, b, and c are constant and a is greater than 0. Alright, so this is referring to the standard form of a line. If we have a equal to 0, we end up with a horizontal line, which ends up not being a standard form type of line. It just ends up being straight across. Y equals, a number. Alright, so the point at which a non-vertical line crosses the y-axis is called the y-intercept, as usual. And the point at which a non-horizontal line crosses the x-axis. Now this we talked about a few lessons ago. You can call this a 0, or you can call this a solution, or x-intercept. It actually has 3 names. So we'll call it an x-intercept in today's work, because that's what we're going to be asking about in the questions. So x-intercept is what we want to put here. But again, it can be called a solution or a 0 of the function as well. We name the special form of a linear equation y equal mx plus b the slope-intercept form. So slope-intercept form. Specifically the slope and y-intercept form. That intercept is a y-intercept, which I pointed out underneath, where m is the slope and b, lowercase b, is the y-intercept. Now that y-intercept is actually a coordinate, so when we say b is the y-intercept, what we're talking about is the coordinate 0, b. So if this was a 3, 0, 3, in other words up 3 would be where the graph crosses the y-axis. Or if it's a negative 3, it would be down 3, 0, negative 3. Down 3 is where it would cross the y-axis. So we commonly refer to it as b is the y-intercept, but it's actually coordinate 0, b in this case. And m again is m can always be written as a fraction unless it happens to be a 0. In which case 0 is just 0, it's not over 0. But m can always be written as changing y over changing x. So that's what we have underneath. The slope formula is equal to, or the slope, which is m, is equal to the difference in the y's goes in the top, the difference in the x in the bottom. The order that you subtract needs to be consistent. So if I'm going to subtract this one from this one, I need to do that every time. If I'm going to subtract this one from this one, I need to do that every time. So the normal order is to subtract the first point from the second point. That's assuming the second point is higher than the first point. And then you do the same thing. Subtract the first point from the second point, its values. You can set it up horizontally. Alright, positive slope rises from left to right. So when you read a graph, you always go from left to right, the x's. So when you're reading a graph, you're always determining from left to right, what does the graph do? From left to right, what does the graph do? So positive slope, on the left it points down, on the right it points up. There is no importance to where the y-intercept is here. It doesn't matter where this y-intercept is at. It can be below, it can be above, it can be all the way up here, it can be all the way down here. As long as it points down on the left and up on the right, that's positive slope. What this means is the second point on each line is higher than the first point. The first point, again, we read the graph left to right. The first points are over here on the left. The second points are over here on the right. Negative slope is opposite of that. The left points are higher than the right points. So if you're reading it left to right, these points on the left are higher than these points on the right. So the line falls from left to right. So the left points up, the right points down, if you want to say that. Zero slope is flat. This is like if you were driving on a road and there's no rise or run on the road, you're just driving straight. It doesn't go up any hills or down in any valleys, like driving through the Great Plains. An undefined slope would be like if you drive off a cliff and you fall straight down forever. An unending cliff that goes down forever and never stops. So there's page 53. All right, next items. Here we're going to find the slope that passes through the point. So again, what I want to do is subtract the points. Now you can subtract in either order. So some of you are thinking, well, which point should I subtract from which? It doesn't really matter, as long as you're subtracting one point from the other. Now my work, I've started to show my work a little bit different than most teachers. What I literally do is I take one of the points and put it underneath the other one, and then I subtract. That's what I literally do. So what I'm going to do here is I'm going to take this point, put it underneath this one, and I'm going to subtract to get my differences. So I got -3, I'm going to subtract -4 from that. That's going to give me -3 minus -4, that's -3 plus 4, that's going to give me 1. That's my change in x. And then on the y's, I'm going to do the same thing. 5, I'm going to subtract 7 from it. -2. Slope is not a coordinate, it's the change in y's over the change in x's. So what I need to do now is put this one over this one as my finished answer. The y over the x. -2 divided by 1. That is my slope. Change in y divided by change in x. So that's one way to show your work. Or if you want to do it differently, that's fine. So if you want to do it this way, here's my first y value, here's my second y value. The slope is equal to y2 minus y1. y2 is -4 minus 8. So that top of that fraction is going to be -12. You could also say that the y's decrease by 12. From 8 to -4, there's a decrease of 12. In the denominator, I'm going to have my x's. Here's my first x value, here's my second x value. These subscripts just mean first and second values. So here I'm going to put a 9 minus -3, the difference in the y's. 9 minus -3, that's 9, plus 3, that's 12. So my slope here is a 1 over 1, because that reduces. You do not have to always write slope as a fraction. I will write slope as a fraction every time because that's what I prefer to do. 1 second, I got somebody over here. Okay, so if you don't want to write slope as a fraction, that's fine. You can leave it as a integer. If it's an integer, this would be -2, this would be +1. What this means is for every 1 it goes up, it goes 1 over. What this means is for every 2 down, it goes 1 over to the right. The bottom is always positive here in the end. We always make it positive. Alright, next items here. So again, you can do slope however you want. If you want to see another way, there's always another way to look at these. So I'm going to have here m equals, in the tops I'm going to have 6 minus 6. In the bottom, I'm going to have -5 minus 1. That's 0 over -6. My slope here is 0. You can make that 6 in the bottom into a positive 6 and say it's 0 over 6. Or you could simply say it's 0. The slope is 0 over, I don't care what you put in the bottom as long as it's not a 0. Or if you want to leave the bottom blank, leave the bottom blank. Because it goes up 0 and over however far you want to go over between those points. Because connecting these points is a line, it's a horizontal line at y equals 6. In other words, this line looks like this. Every point is up 6 on the y-axis. So it doesn't matter how many you go over, you're going to get to the next point. So 0 over whatever, or just plain old 0. I'll put a 1 here. If you want to put a 1, that's fine. Or 6, whatever number. Next one is kind of opposite of that. So here the denominator is 0. So I get 7 minus 8 over 2 minus 2. This one is special because this one is undefined. Division by 0 is not allowed. This one, in other words, is a vertical line at x equals 2. So this one is the opposite of this one, kind of, where this one goes this way. It's perpendicular, in other words, to this one. This one is just over 2 on the x-axis and just goes up forever and down forever. I don't want the slope written here like this, because 1 over 0 is always wrong to write. Dividing by 0 is always wrong to write. So I want this one to be written as undefined, because division by 0 doesn't work. This one has a 0 slope. You could also put it has no slope. 0 slope, no slope. This one has infinite slope or undefined slope. This is infinity or it's undefined. You'll talk about infinity in college if you need to, what it is and what it does. But this is either infinite or undefined. I don't care which one you put here. They mean the same thing here. They don't always mean the same thing. And this one is 0 or no slope. When you say no slope, it means 0, not undefined. Alright? Alright, what is the equation of each line? So it's just asking for what is the equation. So what I need here for the equation is a slope and a y-intercept. Y equals mx plus b. Now I didn't specify what type of form to use. Well, I did kind of here, slope-intercept form, but I didn't in the questions. So if you want to do standard form, that'd be fine, but we have a slope and a y-intercept here, so that would be kind of what we would want to do here. M is a negative 1/2, and your y-intercept is 0, 3. B is equal to 0, 3. So for my slope-intercept form, y equals negative 1/2 x plus 3. I didn't need to graph. If I want to graph, which is kind of asking me to graph as well here, I'd start at 3 up and go down 1 over 2. Now I'll be specific on a test if I want you to graph. I won't make it kind of open-ended like this where it looks like I want you to graph, but I want you to write the equation as well. So if I want you to graph, I'll be more specific than that. Same thing on this one. M is 3. The y-intercept is at 0, negative 2. So we have y is equal to 3x minus 2. Again, this is the part that you use for your y-intercept, the number, the second number, the y value, because the x on a y-intercept is always nothing. So here we're going to start down 2. Now this slope is the same as 3 over 1. That's why I was saying on question A up above, you should kind of write your slope as a fraction, because we're going to go up 3 over 1. This is not a vertical line. If it was vertical, it would have a slope that's undefined. This line does not go straight up and down 3. It goes up 3 and over 1. So it does have an x component to the slope. You will always have an x component unless your line is vertical. In other words, unless your slope is undefined. If you want to do second point, that's usually helpful to get your graph looking a little better. So I'll try to make it go through where it's supposed to go on the second points. It's supposed to go up 3 over 1 each time between the points. So that can be helpful to make your graph look nicer. Alright, question C, same as the two before it. It just looks like I gave you more space here. So M of 0, y-intercept of 0, negative 4. So B is equal to 0, negative 4. So what that means in terms of your equation is you have y is equal to 0x minus 4. Which that can be simplified because 0 times anything is 0. So this equation I'm going to write y is equal to negative 4 as my linear equation. Now that also looks like a solution. So what we specify here is that this is a linear equation because of the question. Because it's asking me to write the equation of the line. So I know that looks like a solution, but it's a line at y equals negative 4. In other words, it's a line with no slope or 0 slope crossing the y-axis at negative 4. Why do I know it's negative 4? Because that's the y-intercept, not the x-intercept. Alright, write the equation in slope-intercept form. The simplest way to say this is to solve for y. Solve for not x, y. Okay, so to solve for y, we can start off by moving the x over to the other side from the y. So wherever x is, if it's on the same side with y, it moves to the other side. So 2 times y is equal to negative 3x plus 18. I like to put the x first because slope-intercept form, that's the way it has it. It has it as y is equal to mx, and then there's a number after x. You can see mx and another number. You do have to divide by the 2 here because you do not want it to be 2y, we want a single y. So y is equal to negative 3 halves x plus 9. This is my slope-intercept form. My slope is down 3 over 2, or negative 3 halves. My y-intercept is at 0, 9. It did ask for both of those, so those are both what I'm supposed to be doing there. Same thing here, take the 7x over from the left to the right, divide by negative 5 this time. Keep in mind that the signs change when you divide by negatives. So when I divide by this negative 5, I'm going to get y is equal to 7/5 x minus 7. So my slope is 7/5, and my y-intercept is 0, negative 7. There we go. Alright, graphing linear equations. In standard form, it may be easier to graph using the intercepts. However, sometimes the question is meant to be done with slope-intercept form. So take this one for example. I could graph this one with intercepts if I divided 4 into 8, that would give me a y-intercept, and then 3 into 8, that would give me an x-intercept, but that's going to be a fractional x-intercept. So perhaps I should work this one with slope-intercept form. So there's 2 ways to do graphs, slope-intercept form, and then just with the y and the x-intercepts. I recommend if it's giving you fractional values for the x-intercept, you try slope-intercept form and see if that gives you integer values, because oftentimes it will. So this question is kind of meant to be done with slope-intercept form because the 3 doesn't go into 8 evenly. Does that mean you can't do it with intercepts? No. But that simply means it's easier to do it with slope-intercept form because of the way the questions are written. So my slope here is 3 over 4, up 3 over 4 in other words, and my y-intercept is 0, negative 2. So I'm going to start down 2 on the y-axis and then go up 3 over 4 to do my line. Now the x-intercept here is 8/3, which is 2 and 2/3. So I could have graphed it with the x-intercept there as well and got an appropriate graph. If you choose to do x-intercept here, I would be fine with that. So in other words, if you choose to do the intercepts graphs, that's going to be fine with me on this question as well. I would not be that picky about that on this particular question. Okay, next items. These are all the same type of deal. Graph them. Here, maybe let's do the same thing. Let's do the slope-intercept form. So move the 4x over to the 6. Negative 2y is equal to negative 4x plus 6. Divide it in half. Y is equal to 2x minus 3. So I'm going to start down 3 and go up 2 over 1 for each particular successive point. There's my graph. So in other words, my slope is 2 over 1 and my y-intercept is negative 3, which I could have did that with, again, dividing 2 into 6, negative 3, and then dividing 4 into 6, which is 2.5. 2.5, no, 1.5, because it's 1 and then 2/4, which is this point here, the x-intercept. So again, if you want to do that with the x-intercept, that's fine. Alright, this one, all we have to do is move the 1 over to the 2x, and y is equal to negative 2x plus 1. So start at 1, go down 2 over 1 each time. There we go. This one is pretty much set up for slope-intercept form. It's not set up as standard form at all. So this one I wouldn't graph it with the x-intercept. The x-intercept there would be the half. But I wouldn't graph it with the x-intercept because it's much easier just to do the y-intercepts and then the slope there. And then this one is a vertical line. It says graph x plus 2 equals 0. And I have a 2-coordinate graph. So take the 2 from 0, you get x equals negative 2. So that is a solution. That's a solution or an x-intercept or a 0. But because I'm asking you to graph it, I'm asking you to graph a vertical line through that solution. That's what this means. Graph the vertical line through the solution x equals negative 2. And a similar thing would be meant by if you had a y equals 3 and I asked you to graph it. I'd be asking you to graph the line through y equals 3, through the y-intercept y equals 3, not just the y equals 3. Alright, so there's page 56. These two on the bottom are just extra graphs that we could do in class, but since we're not in class, we do them. Next thing here, slope-intercept form. Use this form when you know the slope and the y-intercept. Yep, y equals mx plus b. Point slope form, use this when you know a point, a slope and 2 points. So this says y minus y1 equals m, quantity x minus x1. And I said a slope in 2 points when you know a slope in 1 point or when you know 2 points, either one of these options. So if you're given 2 points or if you're giving a single point and a slope. And then standard form, the only reason you'd use standard form is if it was given. That's pretty much what standard form is used for. When you're given standard form, you use standard form. Otherwise, you don't use standard form. I guess you convert intercepts into standard form. So I gave you an x-intercept and a y-intercept and ask you for an equation. But it would be actually easier to use this if I gave you an x-intercept and a y-intercept, point slope form, than it would be to use standard form. Anyhow, so here it says write the equation with a slope and a point. I'm going to write the equation in point slope form. There's no need to make this into slope intercept form. So let's start off with the variable y minus the y value. So y and an opposite of the y value, so y plus 1 equals m negative 3 times the quantity x minus 2. So again, I chose point slope form here because that's what I was given. I was given a slope and a point. There's the equation. In terms of the graph, start at the point, left one up to, negative 1, positive 2, and then do the slope, down 3 over 1, negative 3, 1, 2, 3 over 1. There's my graph of my line for this particular line. Notice I didn't have to find the y-intercept algebraically. I didn't have to find that y-intercept algebraically. What I did is I graphed the point. Oh, and I graphed it wrong because it's been a long summer. I graphed the point to negative 1. And then I do the slope from there down 3 over 1. Sorry, I was doing negative 1 up 2. I had this point backwards. 2, negative 1, right? 2 down 1. So anyways, this can be useful if you don't want to find this, if you're not asked to find the y-intercept. Now I could use this to find the y-intercept, which would be right there, at y equals 3. But I didn't need to find it algebraically. Same thing applies to this one right here. You're going to take y minus 5 equals 2/9 times the quantity x plus 1. There's the equation. So I can start at negative 1, positive 5, and then from there I can go up 2 over 9. So it's kind of hard to go up 2 and over 9 based on this grid, but that's what I'm supposed to do. So this grid is only 1, 2, 3, 4, 5, 6, 7, 8 long. So when I go up 2 and over 9, I'm going to have to do up to 1, 2, and then over 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it ends up all the way over here actually. So this grid actually doesn't fit this particular line very well. In other words, that should probably be, instead of a 2/9, it should be like a 2/3 or something like that. so it goes through better. Alright, so write the equation given 2 points. So for this, I'll find the slope first. So I'll take the y's and subtract. 6 minus 2 is 4. Then I'll take the x's and subtract. Negative 3 minus 3 is negative 6. There's my slope. And then I'm going to use point slope form. Use either point, it doesn't matter. So I'll take the first point, y minus 2 equals, if I want to reduce that into 2/3, that's fine. Negative 2/3 times the quantity x minus 3. So I'm going to start at this point, 3 comma 2. 1, 2, 3, 1, 2. 3 comma 2. And then from there I'm going to go down 2 and over 3, or I could go down 4 and over 6 if I wanted, either way. So down 2, 1, 2, 1, 2, 3. So again, we always go to the right when we go over, we don't go left. So that's why I put the negative with the 2 part of this fraction, not with the 6 part, the 3 part. We always go to the right when we do these, when we're graphing these. Unless the grid doesn't fit, then we can go left and up instead, or left and backwards. So you can switch it around if you need to, if the grid doesn't fit. Alright, next item, finding standard form. So to start off, to find standard form, what you want to do is eliminate the fraction on the slope. So I'm going to start off by doubling everything. Why am I doubling everything? Because standard form does not have fractions. Okay, so I'm going to take this and write it as 2y is equal to 3x minus 8. The second step for standard form is to move the x over to the y. So take the 3x and put it in front of the y, not behind it. So negative 3x plus 2y equals negative 8. And then the third thing with standard form is the lead coefficient, a, should be positive. Alright, so we're going to type this and we're going to times it by negative 1 so that the lead coefficient becomes positive, the x coefficient. 3x minus 2y equals positive 8. That's just a formatting thing that you do with standard form. Sorry guys, I had to get a drink of water. I've been having to get a few drinks of water. I'm good now though, I think. Alright, so what are the intercepts of this? For the intercepts, what you're going to do is you're going to divide the c term by a and by b respectively. So what I'm going to do is I'm going to set 2x equal to 8. So I take this lead term, ax, and I set it equal to c. I'm going to divide that, and then this is going to give me my x-intercept, which is at 4, 0. Again, this is a solution, but it's also an intercept on the x-axis. It's both. It's a solution or a 0, or in other words, an x-intercept. That means the same thing here. So x equals 4. There's 4. You do the same thing for the y-intercept. Negative 4y equals 8, which is negative 2. Now this isn't called a solution. This is called a y-intercept. It's not called a solution or a 0 here. This doesn't have a separate name. And again, it's a point at 0, negative 2. So again, when we say y equals negative 2, that's referring to negative 2 on the y-axis. And then we're going to connect those two points. I was about to say solutions. There's only one of them that's a solution. We can connect these 2 points, and that's going to form our line through those 2 points. Okay, next item. Same thing. 3x equals negative 15. X is equal to negative 5, or in other words, our x-intercept, our solution. And for our y-intercept, 5y is negative 15. So there we have y equals negative 3. So our y-intercept is at 0, negative 3. 1, 2, 3 on the y-axis. There's our graph. Alright, again, if you get confused about this, this tells you which coordinate to use for which. This tells you the y value is negative 3, not the x. This one tells you the x is negative 5, not the y. x is negative 5, not the y. And these do not go together to form a single point. These are intercepts on the grid. This is a solution, x-intercept or a 0. This one's a y-intercept on the grid, on the coordinate grid. Alright, so here we got some a word problem to talk about. So we have a Green-Shields formula. So the amount of time a light at an intersection should remain green is determined by the following formula, where G is the green time in seconds and N is the average number of vehicles traveling in each lane per light cycle. So find the green time for a traffic signal on a street that averages 38. So this one's saying substitute N with 38. So this one's saying at N equals 38, find G. Find G. So what you're going to do here is 2 1/10 timesing by 38 plus 3.7. And I'll let you guys finish that one out. Next one here. How many vehicles will be necessary in each lane for the green time to reach 2 minutes? The green time should be in seconds, not in minutes. So we'll start by converting this into seconds. So I'm going to time this by 60. That's equal to 120 seconds. 60 seconds per minute. So what this one is saying, that G is equal to 120, find N. Alright, so if G is 120, 120 is equal to 2 1/10 timesing by N plus 3.7. You're going to solve that one for N. I'll let you guys do that yourselves. You don't need me to go through that with you. Oh, and this one we're finding G. G is equal to. Alright, so there's page 58. And then our last page for the notes today is page 59. The slopes of parallel lines are equal. So in other words, if the slope on one of them is equal to 3, the slope on the other one is equal to 3. The slopes on perpendicular lines are opposite reciprocals or negative reciprocals. So if the slope on the first line is 2/3, the slope on the second line would be negative 3/2. You would interchange the numerator and the denominator and negate it. You could also have it be negative here and then be positive here. So one of them's a negative, one of them's positive for perpendicular lines. In other words, they're opposite signs of each other, and then they're reciprocal as well. Alright, so to determine whether these two lines are going to be perpendicular, parallel, or neither, you're going to need to find the slope for both. So for line 1, m is equal to 1 minus negative 2. That's going to be 3 over 5 minus negative 1. That's going to be 6. 3/6, which is 1/2. So what would the slope have to be on the second line to be perpendicular to this line? It would have to be negative 2 over 1. So let's work on the second line and see if it's negative 2 over 1. So the top here, negative 5 minus 3 is equal to negative 8. The denominator here, 5 minus 1, is 4. So that's negative 2, which I could put over 1. These are perpendicular. Alright, if you're looking for a quicker way to do slope, slope is always rise to run, so I'm going to present that now. This line goes up 3, negative 2 to 1, up 3, right 6, negative 1 to 5, positive 6. This line goes up 8, from 3 to negative 5, that's actually down 8, down 8, and then right 4, negative 8 over 4. So you can't just look at the points and say, these are 8 apart, the second one is 8 less, so negative 8. These two, the x values are 4 apart, the second one is bigger, positive 4. And here you'd say, well, these are 3 apart, the second one is 3 bigger than the first one, in other words, the y values. And these are 6 apart. The second one, the 5, is 6 bigger than the first point. So that is another option to do slope. I don't expect you to do slope by showing out each and every time the formula. What's the equation of each line? Okay, so for the equations, I'm just going to use these values, the slopes, and then I'm going to use a point, the first point. So I'm going to say the first line is y plus 2 equals 1/2 x plus 1. And then for the second line, let me use a colon here, I'm going to say y minus 3 equals -2 over 1, or just -2, either way, x minus 1. There's my two equations for these lines up above. Alright, so next item, parallel means same slope. What's the slope here? Change in y over change in x. Or I can put this in slope-intercept form. So I'm going to take the 4x over and then divide it by 2. So what I'm going to notice here is that my slope is going to have to be -2. Because you take the 4x over, it becomes negative, divided by 2, -2. So you're going to have y plus 2, sorry, that should be an equal sign, equals -2 times the quantity x minus 4. Oh, and that's point slope form. If I want to make that into slope-intercept, I'm going to have to distribute and then subtract the 2 over. So if I want to make this into slope-intercept, I'm going to have y plus 2 is equal to -2x plus 8. Take the 2 from the 8, -2x plus 6. There's slope-intercept form. It did ask me for it in the question. So I did have to go through and convert to slope-intercept. Most times you don't. Alright, the line perpendicular to this one, so that tells me that my slope is going to be -3/2. Why? Because this one has +3/2. So my slope perpendicular, which you can write it like that, the slope perpendicular is -3/2. That's not the slope given, it's the slope perpendicular because I want perpendicular. Alright, so again, I'm going to start off with point slope form because this is a point. So I'm going to say y minus 6 is equal to -3/2 quantity x minus 0. It did say standard form. So this here is point slope. To get standard, I'm going to distribute this through. Y minus 6 is equal to -3/2 x. I'm going to double everything to get rid of the half. So that's going to be 2y minus 12 is equal to -3x. And then I'm going to put the y on the same side with x and rewrite the equation. So I'm going to say 3x plus 2y is equal to 12. What did I do there? I added 3x over and I added 12 over to there. Okay guys, so that was a longer one again today. Thank you for hanging with me. Any questions again, always feel free to ask. Bye.